So now let's see CPU scheduling. As I have told you, so we'll see long term scheduler, short term scheduler, medium term scheduler. Okay, so now what is CPU scheduling? This deals with the problem of allocation of process to CPU. When it will be in CPU, when it will allocate a process to CPU, and when it will be going to waiting queue, sorry. So this is all done by CPU schedulers. Okay, so there are three types of CPU schedulers. Okay, so first is long term scheduler, then medium term scheduler, and then short term scheduler. So now let's see long term scheduler. Number one, it is responsible for selecting a process from the secondary storage and load that process or job into main memory for execution in a ready queue. Okay, so ready queue and everything we will see in a diagram in a bit. Okay, so there were no space to put the diagram. We will see once all these things. Please write it down somewhere, and then we will move on to diagram, so it will be very clear. For now, let me tell you the theory, and then we will see the diagram. So the long-term scheduler decides whether a new process can be added to the ready queue now by monitoring degree of multi-programming. So multi-programming you have already seen. Like multi-programming means it will choose one job according to it is input output is required. If the CPU is not required, it will it will not sorry, give the CPU time. Okay, so it is responsible for particularly selecting a particular process, and it is stored from secondary storage, and it will load into ready queue. Okay, so that is for long term scheduler. Now medium term scheduler, if a process requests an input output in middle of execution. Okay, so once it is executing and it has asked for input output request. Okay, so then process is removed from memory, main memory, and loaded into the waiting queue. Waiting queue will also we are going to see. So ready queue is different, waiting queue is different. Okay, when the input output operation is completed, then moved from waiting queue to ready queue. Okay, so again it was going to ready queue, and then these two operate, and then again long term scheduler will schedule it. These two operations are performed by medium term scheduler. So if it requests if in the middle it requests input output, it will be put into this waiting queue from main memory, and when the operation is completed, then the job will be moved from waiting queue to ready queue. So now let's see short term scheduler and also this diagram. So the short term scheduler selects a process from the ready queue. So now you can see short term scheduler is here. So ready queue, it selects a process among the ready queue to execute on CPU. So now it will pass through dispatcher. Here one program, that is dispatcher, switch the CPU from one process to another. So here it is dispatcher. Okay, so now let's see, a job is in secondary state. Long term scheduler will select and it will put in the ready queue, and short time scheduler we just saw, it will put it in dispatcher, and then it will move on to CPU. Okay, so medium time scheduler, as you have seen, if IO request is coming or something is coming, so from CPU it will go to IO waiting queue. Okay, and now once IO waiting is completed, this IO completion is done, so it will move on to ready queue. Okay, so this is basically the thing. You don't have to remember all those things I have written, so I have just written to make it clear, but you can just put the diagram in your notebook and some front of you, so that this diagram is like pasted in your brain. Okay, so this is a very important thing. So we will see like CPU scheduling algorithms. Okay, so there are basically we'll like get to it in details, but for now you can see there are two types of scheduling algorithms. One is preemptive, another is non-preemptive. So preemptive algorithm means so we will it is the process is running and it will stop the process, and some other process will start running. Okay, so this is basically preempting the process. Okay, stopping the process, some other processes will go and run. And non-preemptive means nothing will stop the process. Once the process is inside the CPU, it will continuously run, and once it ends, another process will start. Okay, so we will see all these things in details from the next video onwards.